Bismillahirrahmanirrahim. March 2022. Question number 4. A sample of sand has a volume 0.050 meter cube. Volume is given. The density of the sand 1900 kilogram per meter cube, that is given, and the specific heat capacity of the sand is given 1500 joule per kilogram per Kelvin or per degree Celsius. You need to calculate the mass. So volume is given, density is given, so mass is easy. You know the formula that density is equal to mass by volume. So from here I can calculate the mass. Mass is equal to density into volume. So what is density? 1500. What is volume? 0.050. Please calculate, check your calculation also. Let me calculate. When I will calculate the answer, I get the answer 95 kilogram. A2 part, calculate the thermal capacity. So thermal capacity of the sample of the sand, we know that thermal capacity is equal to M into C, specific heat capacity. So mass we just calculated, that is 95, and C is given in the question 1500. Answer according to my calculator 142,500 joule per degree Celsius. I can write it 142.5 kilojoule per degree Celsius. The initial temperature of the sample of the sand is 0.7 degrees Celsius. The temperature of the sand using electrical heater, the power of the heater is given, that is 50 watt. Calculate the time taken. You need to calculate the time taken to increase. So this is calculator, we have to calculate, and final temperature is given. Final temperature is given to us. So I need the time. For the time, power is given. I can use this formula that power is equal to energy over time, and this means that as we know that in case of specific heat capacity, when change in temperature is there, we always use this formula that energy is equal to mc delta T. This delta T shows the change in temperature, and this small t shows the time. So let me put the value here. I can rearrange both these two formulas. I can put, let's say this is equation number 1. I can say this is my equation number 1. I can say this is equation number 2. So I'm going to put the value of 2 in equation number 1. So final shape of the equation I have mc delta T divided by T. So I need to calculate this time. So after rearranging, the shape of the equation is T is equal to mc delta T divided by power. So mc we already calculated here, combined form mc. This is equal to mc. So mc's answer is 142,500. Change in temperature is given 19 minus 7, and power of the heater is given, that is 50 watt. So after calculation, what the answer I got the answer, just give me 1 minute, let me calculate. Yes, I got, I will write the time in hours. So 9.5 hours. This is the time, because I got the answer in seconds, so that answer is a very big answer, so it's better to write in hours. So I divided with 60. So final answer after division, it's 9.5 hours. The last part of the question, the last part, describe in terms of molecule how thermal energy is transferred from heater from heated the sand through the base of the plastic pot. Okay, you can see here in this diagram the heating element in sand, mean a heating element is present in sand. So when heating element will turn on, it transfer the heat to sand molecule. Sand molecule take energy from the heater and transfer to the pot. So what we write that sand molecule, now it's better to write a sand particles. Sand particle gain heat from heated element, from heating element, and then transfer energy to the plastic pot molecule, plastic pot and plastic pot molecules, are better to write particles. Plastic pot particle transfer energy to soil. Last part of the question. The heating element in figure 4.1 remains switched on. The temperature of the sand remains constant at the value above the room temperature. Explain why temperature of the sand remains constant. This is very simple logic. See, this sand taking energy from heating element and then transfer to pot or soil. So heat in and heat out are same. I can write that heat in and heat out are equal, mean sand taking energy from the heating element and then transfer to pot. So heat given to the pot is heat out and heat taken from heating element is heat in. So heat in and heat out both are same, so that's why temperature of the sand remains constant. Temperature of sand remain constant.